Now we can also work with equations that are fractions. Fractions, no big deal, as long as we remember our rule. Whatever we add to one side, we need to add to the other side, or take away from one side, take away from the other side. Now in this particular equation, I have my x on my right side. Before, they've been on the left side. That doesn't matter, because our first goal is isolate the variable x. So, what would you want to add to the right side so that once I did the operation, x is by itself? Well, I have it take away a 2/3. How about if I add a positive 2/3 to that? And if I do that, I need to add a positive 2/3 to the other side as well. So I have a negative 1/2 plus my 2/3. Now notice my equation still is balanced. My second step, I just added the same weight to both sides, so my equation is still balanced. It is still equal, and I can still solve it with integrity. So, solving this, the right side then becomes x plus a 0. The left side, I can add negative 1/2 plus 2/3. In order to do that, I need to get common denominators. To do that, 1/2 equivalent, looks like my common denominator is going to be a 6. So I'm going to have a negative 3/6 plus 2/3 is going to be equivalent to 4/6. Now I can add those two numbers together. Negative 3/6 plus a 4/6 produces a 1/6. On the right side, I have an x. My solution in this case is x equals 1/6. And that's my solution. We could check it. By checking it, we go to the original equation. Minus 1/2 equals x minus 2/3. Actually, I'm going to do it over here. I'm going to run out of room. So minus 1/2 equals x minus 2/3. Insert what I found to be my solution, which was a 1/6. Find out, is this a true statement or not? To find out, I'm going to get them all over sixes, so this becomes a negative 3/6. That's the equivalent expression. 1/6 minus 4/6. Negative 3/6 equals 1/6. Take away 4/6 gives me negative 3/6. That is a true statement. What that tells me is, it tells me my check works. 1/6 is the solution to this linear equation that started with fractions.